Good afternoon, ladies and gents. Welcome to Student's Guide to the Galaxy. I am Martyn.
And I am Ryan. This show, while trying to stay as factually accurate as possible, is for entertainment purposes. In reality, we're a couple of physics students that love all things sciencey but don't always understand them. This means that information could be not completely accurate. But when we're not rambling off topic, we will provide sources.
So, Ryan, how you doing?
I'm doing good.
All right, what do you got for me this week?
Well, this week, things did happen in science news.
It's better than last week.
So we don't have to bring in another guest.
A random guest, yeah.
Yeah, he might come back. You never know.
Maybe.
He's been pushed to the science box.
Yeah, he's in the box now. All right, what you got?
Well, so Rome has been awarded the site of the DDT reactor.
Okay, that sounds fun.
The divertor Tomac test. It's a mouthful.
Why can't scientists name anything nice names?
Okay. It's a really cool thing though. It's a fusion reactor.
Wait, what?
Yes.
I thought fusion was like impossible. Or
Well,
really difficult.
We think that, but you never know. It might happen.
Okay.
Because it's always been 50s off, but you never know. It might happen.
Yeah. So what makes this one special? What makes this like the one that may do it?
This one so we've currently got ITER. ITER, which is a reactor test site in France.
Okay.
And it is fusing plasma, but it can't take out of the energy it creates, but it can't divert the energy away.
Okay, so it's making all the energy, and then it's just what the energy is sitting there because they can't get it.
So
okay.
it's a tokamak. That's it. The tokamak. There we go. I said the word.
Yeah,
right.
great.
It's a tokamak, which is a donut shaped ball of plasma.
Is it sponsored by Krispy Kreme?
I'd love it to be.
That'd be amazing. Sorry, go on.
It's a donut shaped. It's a donut shaped ring of metal which holds a donut of plasma with very high intensity magnetic fields.
Right.
With giant superconducting coils of magnets because, of course,
well, yeah,
fusion couldn't get any better.
Mm-hmm.
And it's held confined in a ring. And it heats up and fuses and gives out energy, but we've got no way of harnessing that energy at the minute.
Okay, so remind me quickly, the fusion is the stuff that's powering the sun, right?
Yes.
Right, so we're basically harnessing a tiny sun.
Yes.
Right.
A tiny ring-shaped sun.
A tiny donut sun.
Yes.
Because scientists are apparently obsessed with donuts.
Yeah.
Which I'm fully behind, by the way.
And then what they're doing, so to get out the energy, what they're going to try and do is they're going to try and divert some of the heat downwards to a core at the bottom, which will heat up and transfer the energy, probably to water to drive turbines.
Yeah, so once it gets to that point, it'll do like every other power station.
Yeah,
it'll just boil water, get steam, turn turbines.
Everything runs off water. It's weird.
We got enough of it, so
yeah. But you would have thought at this point we'd have some higher tech way of generating than lots and lots of steam engines.
Just steam engines everywhere. Every power station is a glorified steam engine. I love it.
It is. It's weird.
Okay, so what makes it so? How much was this? This thing couldn't have been cheap.
No. So
No.
ITER, its predecessor, cost 2 billion euros.
That's right. Okay, that's a significant chunk.
This one is costing 500 million euros to start with.
Sorry, I've got a pain in my wallet. Sorry.
500 million
500 million
euros, and that's to start with. That's base cost that they've said, but as it's a fusion reactor, the prices will probably spiral as they figure out more and more technical difficulties.
That's horrible. Right. So, but the thing is, surely fusion, and once it gets going, it just keeps going.
Yeah,
I would think,
and the thing about fusion, it's very clean. It doesn't create any waste, and also, it creates some waste in the form of slightly radioactive water.
Right,
but that can be stored fine.
Mm-hmm.
And also, the only fuel it needs is refined seawater.
Oh, really? Only seawater?
Only seawater.
So I don't need like just loose hydrogen or anything. Because I remember hearing about a problem was fusion required hydrogen, and getting hydrogen off stuff just on its own is a pain.
There's a very special method you do. You need to put in hydrogen at first. You need to get a ton of hydrogen and put it in.
Right.
But once you've put the hydrogen in, you just need to keep replenishing refined seawater, because refined seawater, some of seawater has something called tritium,
right,
which is basically heavy hydrogen.
Heavy hydrogen.
Heavy hydrogen. No, heavy helium, sorry.
Heavy helium.
Heavy helium.
So heavy balloons.
Yes.
Right.
You want to get heavy water. Don't quote me. It might be heavy hydrogen, heavy helium. I don't quite remember.
You know what? I'll believe you.
But you get heavy water and you refine it into this tritium, and you keep putting the tritium in, and it keeps running because the tritium replenishes the fusion reaction.
Okay, is there any like potential for horrific disasters?
It would sound like it, because you are running this at the temperature of the core of the sun.
Yeah, that seems like
hundreds of millions of degrees.
Explode-y kind of situation going on here.
But the thing is, if you don't keep inputting energy, if you don't keep inputting fuel, if you turn off the magnetic confinement, the plasma won't be able to sustain fusion and will just expand into just a normal cloud of gas.
Oh, so if it goes crazy, like, you know, alarms, sirens blaring, like fusion reactor going crazy, you just turn it off.
Yeah.
That's amazing. So you just literally unplug it. It's a turn off and turn on again.
Yeah.
That applies at that level.
Hilariously, one of the fusion reactors, which isn't a tokamak, it's a pulse. It's a pulse facility, which is heating a pellet of deuterium to very, very high temperatures.
Right.
They figure out if anything. They have many computer systems in place, but they have one very simple system.
Is it Control-Alt-Delete?
No, they have microphones throughout the reactor, and then in the reactor control room they have a ton of speakers in the ceiling in about the same place, so it's localized.
Okay.
And because apparently humans are very good at spotting that doesn't quite sound right, that sounds a little bit out of place.
Really?
And so if they could hear that it's out of, they have found mechanical faults in that. They heard a weird clanging, they localized where it was in the room, and that corresponded to a place in the reactor, and it was a disconnected pipe somewhere that we managed to fix.
So there's a fusion reactor that's being held together with people going, hang on a minute, that sounds weird.
Yeah.
Oh,
Reassuring, isn't it? And
that's hilarious.
But the thing is, you can unplug it and it will be safe.
Yeah, that is one thing that's very bad, because like you hear about like, oh, if your nuclear reactor goes crazy, then, you know, Chernobyl happens, or something like that. Like, but this is, it seems to be the holy grail for the energy crisis that's going on right now.
Well, there is a fact that it is a lot of hot gas which could expand very quickly.
Right.
But other than that, it's just hot. It's not radioactive hot gas. It's just hot gas which will dissipate into the atmosphere.
Awesome. Right. Okay. So, Ryan.
Yes.
What's next?
Well, next is a piece of UK news.
UK news, right?
Yes,
okay.
And it's led me to read my favourite sentence in quite a while.
Do tell.
Right.
I wait with bated breath.
Okay. This is talking about an accelerator in Hamburg.
I thought you said it was UK news.
We'll get onto that. But
okay.
It's a 3.4 kilometre long underground facility that produces X-rays by accelerating electrons in a superconducting linear accelerator to produce coherent laser-like X-rays.
Good lord, that gave me a headache. Right, okay, so hang on.
So
super duper fast X-rays cause of really cold magnets.
Yes.
Right.
In Hamburg, there is a linear accelerator which accelerates electrons.
Right. Same sort of thing they've got at CERN, right?
Yeah, kind of like CERN, but a lot slower.
Right.
Which is then harnessed to create X-rays.
Okay. To what end?
So the
or
X-rays...
just a really, really quick medical procedure?
They're... That'd be brilliant. Right in, and now you're done.
Yeah, right, okay, bye.
No, so it's producing X-rays X-rays in the style of a laser. So
a laser of X-rays.
A laser of X-rays.
Why? What?
Well, because X-ray lasers are very hard to create, and it's very hard to create what's called coherent X-rays.
Okay.
Coherent X-rays is when all of the X-rays are the same sort of energy. They are the same sort of energy level, and they all move as one. And it's how lasers work. There are lasers that are coherent light, and now we're made kind of laser-like X-rays with this.
Okay, all right. So they've made the X-rays.
Yep.
And we've got these amazing coherent X-rays in a laser beam that's going at the speed of light or whatever.
Yep.
Why?
Well,
the ultimate question. Why
the best thing is that this facility then uses fiber optic cables just to distribute this for all sorts of experiments.
Okay.
One of which being you can use these X-ray lasers to image very small things very quickly, so you can create almost movies of, say, bonding or or vibrational energy.
Oh, that's awesome. So like it's basically just a way to do it's an electron microscope just so many times really, really quickly.
Yeah, it's an electron microscope, but fast.
And it's running
Very
through fiber
fast.
optics.
Yes.
The same stuff that internet comes through.
Yes, it is.
Okay.
It's being transferred via, and it could be potentially being built. A fiber cable could be being built to the UK just to send this.
That's a long cable.
Yes, from Hamburg.
That's a very long cable. As cables go, that's a pretty long cable.
And
I don't think I could get that in PC world.
So the reason this is UK news is because UK has now officially joined the collaboration that is this accelerator.
Okay. So are we just like, so we can get the X-rays beamed to us to do all manner of weird experiments?
And because we've sent money, and we're creating equipment to send to the site.
Oh, okay.
So we've built at the STFC.
The ST what?
STFC. It's a
Is it another horrible acronym?
It's a science centre.
Okay, right.
In the UK, it probably is. I dread to look it up.
Just leave it. Pass it off. It's fine. Yeah.
I will. They've built femtosecond laser cameras.
Femtosecond. Right.
Femtosecond
okay,
laser
I know
cameras.
milliseconds. I know nanoseconds. What is a femtosecond?
So
Milli. Yeah.
Micro.
Okay. So this is going down in powers of 1,000.
Yep. Nano.
Yeah.
Pico.
Yeah.
Femto.
So that's 1, 2, 3, 4.
Yep.
Good lord.
That's
so
one.
That's minus 12.
That's 1,000 millionths of a second.
1,000 millionths of a second.
1 million millionths of a second.
A million millionth of a second.
Yes.
That's fast.
Yes.
Right. Okay.
And
you know when you get to like numbers like that, when it's like, oh, I don't know, a bajillion stars in the sky, or
it
a
just
femtosecond.
doesn't make any sense.
It's like I don't know what that means.
So we're using a rotating mirror and a laser.
No, this was on one of our problem sets. I remember this.
Using a rotating mirror and a laser, you can take a picture. And with this, researchers have before taken a movie which is you can see light moving.
Wait, what? You can see light moving? Yes,
they opened a box, they shone a light into the box, and you can see it bouncing off like an apple, or it's on YouTube.
That's awesome.
And so this is what we've produced a femtosecond laser camera.
That's ridiculous. Okay, so we're taking snapshots every millionth of a second.
Yeah.
That's a lot.
Yeah.
It's better than 60 FPS then.
Yes.
Right, okay.
A lot better. Yes, so they've produced this femtosecond laser camera. I hope it could just be a femtosecond laser, which is a very powerful laser.
Okay.
But it can be used for a femtosecond laser camera. So,
what's the benefit of a femtosecond laser X-ray camera thingy?
So a femtosecond laser can be used for a multitude of things.
Okay.
Because it's very, very short pulses, which are a millionth of a second apart.
Okay.
So you can use it for bombarding something with lasers, but not a continuous beam of laser, and it will behave differently to the way you bombard it.
So it's like repeated punches as opposed to like one push.
Yeah.
Right. And this is what I love about science, is we do these amazing things, or I say we, scientists do these amazing things, that actual scientists do these incredible things that just like mind boggles at what they've been able to achieve, and then you're just like, what is the point? It's like they just do
you've done this cool thing,
done an amazing thing, and it's just like, okay, great, I can obliterate an electron with X-rays now. Fantastic.
It's like gravitational waves. We've detected them, but
no, because I think gravitational waves are they're much more. You can easily see how they'd be used.
Yeah.
Because you can figure out, okay, so we can see past the 400,000 year mark in the age of the universe. Because previously, without gravitational waves, we could only we could only look back up to 400,000 years, roughly.
Yeah.
380, something like that. And with gravitational waves, we can see past that.
Hopefully.
But a camera that takes a million pictures every second and can form a movie, which is awesome. Why?
But you can. This means you can see smaller and smaller things and learn more about the world.
Okay.
Although the thing, we'll still never be able to image anything smaller than an atom because of the fun thing.
If you say the Heisenberg uncertainty principle.
Yep.
Oh, right. No. Quantum. I'm calling it. No, we're not talking about quantum. It's not happening.
Yep.
Makes my head hurt too much. Okay, so like, and this is just, and so where was it? Sorry, they've made this Hamburg, was it?
Hamburg.
So Hamburg have got this laser, and they're gonna fire them over here.
Yep.
At a million every second through an internet cable.
Yes.
Right. And then we're gonna take lots and lots of pictures.
Yes. And use it to...
The storage must be incredible. Like, in a second, you've used like 4 terabytes worth of data.
Yeah, you're probably going to have to have the other... So as you go down, you're going to have to go up in thousands of megabytes as well.
Yeah, no, thousands of gigabytes. Thousands of terabytes.
Yeah. Yottabytes.
Oh, no. We're getting too big now. So it's become sort of a tradition on this show that we need to talk about Elon Musk at some point.
And we haven't yet.
We've yet to.
Let's rectify that.
Yeah, what do you got for me on Elon Musk news?
Well, are you ready for the newsreader voice?
Okay, newsreader voice.
A joint US-German mission has gone into orbit to weigh the water on Earth.
Wait, what?
Yeah.
Wait.
Weigh the water on
Earth.
The grey satellites are replacing a pair of highly successful spacecraft that stopped working last year.
Okay.
So not only are we going to weigh the water on Earth, we've been doing it since about 2002.
You need to pause right now. We've been weighing the water since 2002. Has it changed much? Like, have we gained more water? Because I'm pretty sure, like, conservation
when
of
suddenly
water. Yeah, just a pit. Like, we just get hit with a giant water balloon from space or something. Like, how
the
did we
moon
get?
is actually just a giant water balloon.
Oh, it's so clear.
Yes.
But what's the purpose of weighing the water on Earth?
What this mission is actually doing is weighing the distribution of water. It's weighing where water is.
That makes more sense.
And so it's weighing the change in water. Because obviously, water weighs more than ice.
It does indeed.
By random coincidence, ice floats, and so life is possible.
Wow. Yeah, but okay.
Yeah, but aside from that, water is heavier than ice, so we can see as the weight of the water on the planet changes, we can see climate change.
Okay. Oh, so it's another proof of climate change, basically.
Yeah.
Right. Okay.
And also, we can see large droughts. We can see large rainfalls as well, where the Earth has bulged slightly because there's more water there. How do we measure it as well?
On the equator, when it's like it's not actually a sphere, it's more.
It's the fact that there's a little bit more mass there because there's more water there.
Right. Okay.
Purely, there's more water there, so the gravity. This is how they measure it.
Mm-hmm.
Is actually a little bit stronger there.
Oh, right.
Than it was before, and they measure this by being a set distance apart from each other, and then using X-rays, coincidentally,
is it
lasers.
An X-ray laser of doom?
X-rays and lasers, not an X-ray laser.
Okay.
We're not beaming the X-ray laser
into
space, unfortunately.
Just a really long fiber optic cable, just plug into the satellite.
Yes, it's trailing down,
exactly,
spinning around the Earth. Who needs a space elevator when you can have a fiber optic cable?
Exactly.
To space.
So so it's measuring climate change.
It's measuring the distance between the satellites, which measures the gravity of the Earth that it's going over, which measures the weight of the Earth it's going over, which measures the amount of water going over the Earth, which measures the water from climate change and from rain.
Just rain.
Rain.
That's I can just imagine how horrible that would be to compute. How many sums you'd have to do. Oh no, disgusting.
No, you don't want to do that.
What's the so you've got these things and they've been doing it since 2002. Has it changed? This is
the part that Elon Musk comes in.
Oh yes.
SpaceX has launched 2 replacements.
Right.
Called the Grace mission.
Okay, was this on the Falcon again?
Yeah, this was on the Falcon. The new one, which we can talk after we've done another stupid acronym.
Oh God.
The Grace satellite.
Yeah. I thought Grace was just a name.
No.
Oh, no. Right. Okay. Hit me with it. What we got?
The Gravity Recovery and Climate Experiment.
Can I be employed by Elon Musk to just make up names?
It's not Elon Musk's thing. It's a US thing. Yeah, he's just launching. Elon Musk is good at making up names. SpaceX.
SpaceX is a cool name.
SpaceX.
Tesla.
It's like, as a kid, you were asked to make a space company. What do you call it?
SpaceX.
SpaceX.
Because X is a cool letter, as we all know.
Yeah, it's the coolest letter. So you just add it on the name of the coolest thing in the universe, and then you've got...
Then you got his company.
Yeah.
Okay, so you said he's changed the Falcon, which is his massive, the latest in the rocket series, right?
Yeah. So his Falcon 9, which is the smaller one.
That's a smaller one.
That's a smaller one. It's not the Falcon Heavy, which is made up of 3 Falcon 9s.
Yeah, that is quite ridiculous.
Because
bolt 3 little 9s together.
that all land themselves because, of course.
Yep. Well, I mean, that's the only way to do it.
Two of them land simultaneously, and one lands in a drone ship floating in the middle of the ocean.
I mean, what else?
Yep. So he's changed the Falcon 9, and so from what he was calling Block 5 to Block 6.
You know what we were just saying about him having cool ideas for names? I take that back.
I know.
Sorry, Elon, but Block 5 and Block 6 is kind of...
It's the revisions of the revisions of the Falcon.
Okay.
So
what's he changed?
He's painted them. He's painted them black.
I love the idea of him going into a auto dealership or whatever, or a garage or something, and saying, "Hey, can you paint my vehicle?" And I'm like, "Yeah, sure." It's like, "It's all right, cool. I'll bring it in a second." He just tails in this like 100-foot long rocket.
Yeah. It comes in with a rocket payload. Just
it's like, yeah, if you could just get that black, that'd be fantastic. See you in a week. It's just like that paint guy's. Oh God, no! What have I got myself into?
Why did I agree to anything from Elon Musk? That was the worst idea you could have feasibly made.
Well, he'll get paid, that's for sure.
And the best idea you could feasibly make as well.
Exactly. So he's painted it black. Okay.
Okay.
He's only making it look cool.
He's only painted certain sections black. He's painted the bottom. He's painted a strip on the side, and he's painted the top.
He's made a zebra rocket.
He has.
That's amazing.
More of a penguin rocket.
All right, penguin rocket. All right, I'll let you have that one.
But so why is he painted in these? Well, it turns out black isn't just using any ordinary black paint. He's using a heat-resistant black paint.
Okay. Heat-resistant black paint. All right.
Because as your rocket's going up in the atmosphere, it's experiencing a lot of thermodynamic pressure.
Okay.
A lot of heat.
Yeah, right.
A lot of heat from the atmosphere rubbing against it.
Yeah, because it's basically friction, isn't it?
Yeah, it's a lot of friction. Yeah. And then as it's coming back down to land, it, of course, go back down to land. Yeah. Because rockets do that.
Yep, they land just ready to go on the next one.
Yeah.
Well, it's like, because you saw that when the shuttle was coming down, didn't you? Because it landed kind of...
Yeah, and the black tiles underneath.
Yeah. Was that the same? Is it the same kind of
sort of idea? Yeah. And also black, because black's very good at absorbing heat instead of heating up and melt. And yeah. And so what you do...
Had enough Falcon explosions, I think, for a while.
So what you do is you paint it all heat-resistant black, and it's protecting certain specific areas. So it's at the bottom, because as it's plummeting through the atmosphere going down to land, it fires its rockets.
I don't know why, but the idea of a rocket plummeting is quite worrying.
Yeah,
you know what I mean? That specific word is like, it's plummeting to the earth. It's like,
well,
oh God.
I hate to break it to you, but for most of the trip back to Earth, it is plummeting.
It's just plummeting.
It is plummeting.
Okay.
It's a controlled plummet.
A controlled plummet.
But it's controlled by practically 4 tennis rackets on each of the. Because they're called grid fins. They look like
rackets.
They look like tennis rackets.
Oh dear.
And that controls where it's falling. You don't boost back to Earth. You just fall.
I love science.
And
it's
then
ridiculous.
when it turns its engine on it turns the engine on at the end to slow down to a point where it's safe to land.
Mm-hmm.
As it does that, it's going through its own smoke and exhaust trail.
Okay.
Which is rather hot because it's just been burnt, and so the black painting on the bottom is to protect that.
Mm-hmm.
And then the strip on the side is to protect all of the cables which connect the mechanisms in the base of the rocket to the computer in the top of the rocket.
Basically the rocket's spine.
Yes.
Right.
It's the spinal cord of the rocket.
The spinal cord of the rocket, yep.
And then at the top, the grid fins are now painted, and it's now a new material. They were aluminium before, they're now titanium.
Okay.
Because they're just stronger.
Yep. Titanium is better.
And the top of the rocket is also painted black because it experiences the most aerodynamic stress when it's coming down.
And also when it's taking off, it's the one hitting the friction most. Okay, so he's basically just getting the key areas and then leaving the rest white, I guess.
And then he's doing this so it's easier to reuse rockets, because
go ahead.
He wants to just land the rocket, reuse it, and
just keep running it.
Yeah.
Is there going to be a Tesla in it?
Maybe when it goes to Mars.
There's already one going.
There's already one going around to Mars.
You know, I saw a video of the Tesla Model X, which is the big 4x4 with gull wings, because it has gull wings for some reason.
Yeah, of course.
It has enough torque to tow a jumbo jet. It was towing. It was towing instead of a you have like in the airports.
I believe I did see that. It was a video. Yeah, I believe I did see some of that.
It was literally they drove it off the road straight onto the tarmac, and it was just towing this.
Towing this
jumbo jet, and I'm like saying here like that's ridiculous how much torque that thing has.
How does he do it? What does he do?
I don't know. I'm pretty sure he's an alien.
Has he bribed the aliens?
No, he's just an alien just trying to get home. That's all he's doing. That's all he's doing.
He's decided that no, I need to get out of here. Let me back.
This planet, please get me home.
Yeah. That is unfortunately all we've got time for today. But you can catch up with all the rest of the episodes at Student Guide to the Galaxy. They will be up by the end of the weekend, I promise.
Hopefully.
Yeah. Well, we've been very busy, and so editing has kind of taken a backseat, but now that we're not busy, I can definitely do that.
Yes, exams are fun.
Because we can't put in the music, otherwise we'll be copyright striked, so...
Yeah, but we can get it done.
Yeah.
But yeah,
by the end of the weekend, hopefully that'll be up. You can also email us, if you want to, at studentsgalaxyguide@gmail.com.
Check out our YouTube channel, Students Guide to the Galaxy.
Student Guide to the Galaxy.
And, yeah. Any last words, Ryan?
Elon Musk forever.
Elon Musk forever. What a way to go out. All right, then. Thanks, guys, for listening. See ya.